Okay, hello everybody. I'm starting off sharing my screen because I want to just talk about Hawks and probably work through some of the homework for the problems that we did, or rather for the section that we did last time. Uh, so don't forget that over here, if you've got things that are overdue, that you can go do those for I almost said extra credit, not extra credit, for partial credit, right? If they're late, you can do them for partial credit. um, and the ones that are due later, obviously, for the next chunk of material, which is chapter 4 and 6, that is over here. Okay, I don't know why this exam 2 should be in here too, but whatever, don't worry about that yet. Okay, so we talked about 4.1 rates and unit rates last time. So I just want to go through and look at the homework problems just to make sure that we're all on the same page here about how to handle these problems. So it's kind of weird just talking to Hawks. I feel like I'm paranoid that I'm gonna go find out that Teams has been closed this whole time. That's why I keep checking. Okay, so let's look at this problem. Suppose tortilla chips cost 32.5 cents per ounce. What would a bag of chips cost if it contained 20 ounces? Round your answer to the nearest cent. Okay, so by the way, that last part, round your answer to the nearest cent, that means we're rounding to the 100th place. It means we're rounding to the 100th place. So, well, at least if we're writing our answer in dollars, which we are because the little symbol there is dollars. Okay, so tortilla chips cost 32.5 cents per ounce. That's a big hint. The way the units are written there is a big hint. Cents per ounce. So we'll say, let's see, how fast can I do this? Back to my, okay. So start off by writing the unit, writing that rate down. 32 point, whoop, okay, 30, oh my goodness, what is happening? 32.5, and then I can say cents, there's the cent symbol, per 1 ounce. OZ for ounces. If you didn't know, that's the abbreviation for ounces. I don't know why it's a Z. Okay. What would a bag of chips cost if it contained 20 ounces? Okay, so we know that a bag of chips costs 20 ounces. So what do you feel we should do here? Does anyone have any ideas? Like, what's your intuition telling you we should do with the 20 ounce? What do we do with these two numbers?
Get them in the same denominator.
We could do that, but they already do actually, because this one is technically over 1.
Oh, well, yeah.
Yep. But what operation between these two should we do?
Multiply.
Yeah, we will multiply. We will multiply these two. And sometimes, with problems like this, if you're at the store and you see this and you're doing it in your head, then most of you would say multiply, right? But then when you get in the setting of math class, you think that maybe, you a lot of times I tell you not to trust your intuition, right? Or that things are counterintuitive, so then you stop trusting your instincts in math class. But here it's okay to, because that's exactly what you should do. You should multiply. And if that's not enough for you to understand this, think about the units canceling here. We want ounces to go away, right? And money to remain. Money's on top right now. I've got ounces in the bottom. If I multiply by these ounces, all right, just rewriting it here. If I multiply, these ounces are going to cancel like units. Like literally the word cancels out. And I end up just having to do 32.5 times 20, well, if my calculator would play along, which is 650 cents. But they want our answer in dollars. So 650 cents to get it in dollars, right? You know, probably most of you just naturally know how much this is, but technically you divide by 100. And why am I dividing by 100? Because there are 100 cents in a dollar, and then I get $6.50. I could even write this little step here using units. I could even do this. I could say, look, I've got, you know, 100 cents per dollar, per $1, right? 100 cents per $1. So if I've got 650 cents and I want the cents to go away, but as I've written this fraction, cents is on top, how do I invert that to make cents go away and dollars remain? Well, I divide by that fraction, right? I divide by the 100 cents over $1. And why is that legitimate to do? Because will the cents actually cancel here? Well, yeah, because if you recall the way we divide fractions, you flip, here I'll write it as a times, you flip the second fraction and change the operation to multiplication. So you still end up with 100 in the denominator. Like you're still dividing by 100. You're still gonna scoot the decimal point twice to the left and all that. You're still gonna get 650, 6.5, right? Rather. But you can see here when I explicitly write it out all like this, that the units are still, those cents cancel here, and I'm just left with the unit of dollars, which is exactly what I want. So there's always ways to make these problems more technical, right? More technical, and if you do the technicality right, everything comes out looking exactly as it should. You should only get as technical as you need to, though, right? So if in this problem, you don't need to write out all this unit stuff to know that you should just multiply, that's okay. But just know that it's there, because later in your other classes, like especially if you're taking like any kind of sciences, this process of canceling out the units is just so critical. So and it becomes harder later on, and your intuition will fail you in like physics, chemistry, stuff like that. So it's better to have a process to fall back on. Okay, so let's go back to screen share. I'm not obviously going to do every problem. I just want to show you all a few. And by the way, so when we're writing our answer here, you will want to write the 0 behind the 5, 6.50, because that's just how we write money, right? That's how we write dollars, American dollars and cents attached. So you wouldn't just say $6.5, you'd say 6.50. All right. Yes. All right. Okay, so this one says a cell phone service provider advertises its competitive price for international calling on mobile phones as 1 minute for 27 cents to call Germany from the US. Enter that rate in the answer boxes and select the appropriate units here. So here's the thing. I get to choose which way I'm going to write this, this rate. I could put minutes over cents, or I could put cents over minutes. I'll put cents over minutes. No. I'll put minutes over cents because that's the way they listed it up here. They said 1 minute for 27 cents. So they're kind of putting it in order there, minutes, then cents. 1 minute for 27 cents. That's all there is to that one. They didn't ask us to write it as a unit rate or anything like that. It just says rate. So this is all they want here. Okay, this one looks a little scary, but it's not too bad. It says, given the cost for several of the same grocery items in 2 countries, find the rate of the total cost for these items in Australia to that of the total cost of items in the Netherlands. All right, so they want Australia and the Netherlands, which is oh good, sorry, which I guess they use the euro, and I don't know what AUD means. It means like Australian something dollars. I don't know. Okay, so all we're gonna do is we're gonna add up these numbers. We're gonna add up 2.49 because they're asking for total, right? Oops, I'm gonna add right. They're asking for a total 5.62. So I'm getting 21.23 for the Australian total because they want the rate of total cost. Okay, and then I'm going to add up all of the Netherlands cost, 1.14 plus 6.14 plus 2.05 plus 3.36 plus 2.58, 13.27. And as long as I added all those right, that's all they want there. Yep, cool. Here we go. This is another one I wanted to try. It's kind of in the same vein as the first one. You guys still with me? Let me make sure. Yes. Okay. Whoa. Oh, okay. All right. So suppose potato chips cost 25.5 cents per ounce. If a bag, okay, let me write this down, and then I'll switch to my camera. If a bag costs $3.35, how many ounces are in the bag? Okay. And round to the nearest hundredth if necessary. So we're not looking for money this time. We are looking for number of ounces in a bag. Okay. And what was the other number? $3.35. All right. Any ideas? What's the first step going to be? Or what's something that you notice that we should do before we do any operations with these numbers? How about that this one is in dollars, whereas this one is in cents per ounce? Right, this one's in dollars and this one's in cents. Let's get those on the same page. So I could convert this to dollars per ounce. That's pretty easy. Just scoot the decimal point out twice to the left. But then I would have like a decimal, like an even worse decimal number, 0.255. And then when I do my math, they're both going to be decimals, which is fine. I mean, if you have a calculator, who really cares, right? But just for the, if you were to do this by hand, the way you would do it is you would convert this one to cents because it's just going to look better, right? Instead of having them both being decimal numbers, I'll convert the dollars to cents. That way that one turns into a whole number. So it's 335 cents. $3.35 is the same as 335 cents. Okay. So now the thing I need to do is cancel the ounce or the cents and end up with ounces in the top, right? But ounces is in the bottom. So what do we do here? What do we do? We know a unit price of cents per ounce, and we have a number of cents. So what we're going to do is we're going to take that total and we're going to divide by this rate. And how do I know to do that? Well, because I know that I need ounces to end up on top. Like my end result should be ounces. That's what the problem is asking for. My goal is to have ounces, and if I want ounces, it needs to be measured on top in the numerator. The only way to achieve that when the rate is written this way is to end up dividing by this thing to flip it. That's the only way to get ounces up top. And in fact, that's going to make everything else work out really nice with my cents, because when I change this problem and when I invert this fraction and change the operation to multiplication, the cents are going to cancel. The cent symbol is going to cancel. And what's left for me to plug into my calculator is 335 divided by 25.5, which is going to give me 13.137, etc. So I would round to 13.14 because they told me to round to the hundredth place ounces, because that's the only unit that remains, right? It's on top. Everything worked out nice there. 13.14 ounces. Okay, so if I go back to, oh, where is it? There it is. All right, 13.14. Point, not 1,300. There we go. Cool. Okay, so what else do we have? 4 pounds of sugar cost. All right, so this one, 4 pounds of sugar costs $3.40. How much sugar do you need, or do you get per dollar? This is a straight up unit rate problem. They're giving you a rate of pounds, 4 pounds per $3.40. Now, what we need to be careful of here is, I said this last time, we naturally want to put money on top because that's what a unit price is, and that's how we think about things typically, right? But this problem is asking for, if you notice, pounds per dollar here, pounds per dollar. That means pounds is on top and dollars is in the bottom, which is not super natural to us, but it's, you know, they're just making sure you're paying attention here. So since it's in pounds per dollar, that's going to tell me which way I'm supposed to divide to create my unit rate. So I'm going to do 4 over 3.40. So 4 pounds divided by 3.40, and that's my unit rate in pounds per dollars right there. So the way to interpret this is, oh, you probably can't see my calculator, but I got an answer of 1.18 if I round to the hundredth, 1.18. So the way to interpret that is that 1.18 pounds of sugar costs $1. Okay. All right. This is a proportional problem. You know what, maybe I should do this one too. I think this is going to be the last one I do, and then we're going to move to 4.2. You're making dessert, but your recipe needs adjustment. Your chocolate chip cookie recipe makes 2 dozen cookies, but you need 3 dozen. So you're scaling up. You're scaling up. If the recipe requires 1.5 cups of sugar, etc., how much of these ingredients are necessary for that 3 dozen cookie recipe? Now, I'll give you a second to write those down. Now, if you have done any baking or anything, then you know this is legitimate. This is a legitimate math question that you have to deal with over quarantine. I don't know if any of you guys are the ones, you know, that picked up like baking bread or anything, but I picked up baking a little bit, and just for fun. And yeah, this is definitely something that comes up. Some recipe websites have little things built in where, you know, you can change the recipe and it scales it up or down for you. Like you can change the amount of the total end result that you want, the number of servings, and it'll automatically adjust it for you. But not every website or recipe has that. All right, so let's go back to my camera here. So we've got 1.5 cups of sugar. I'll just say C for sugar, cups sugar, 3 teaspoons of salt, 3 TSP salt, and 1 1/3 cup pecans. And of course, if you're actually making cookies from scratch, there would be like a few more ingredients, but this is just a scaled down, you know, the problem is it's just giving you 3 things to convert. So this is for 2 dozen cookies, but we need to make 3 dozen cookies. So how do I set this up? I'm going to say it's all about proportions. It's all about proportions. I'm going to say, starting with the sugar, 1 1/2 is to 2 dozen cookies. Here, I'll go ahead and put cups. I'll go and write the unit here. Cups of sugar is for 2 dozen cookies. 2 dozen cookies should be equal to some unknown number of cups of sugar per 3 dozen cookies. That's going to be the proportion here. That's going to be the proportion. Okay, so how do I deal with this? Well, remember we said the shortcut last time is to just cross multiply. So I need to do 1 1/2 times 3 and 2 times x. Since 2 times x is easier, since that's easier, I'll just go ahead and say 2x, right? That 2 times x is just 2x. Okay. Now, what about the other product here, 1 1/2 times 3? Well, you gotta know your fraction arithmetic, right? So I'll do it up here. We're gonna have 1 1/2 times 3. That's the same as, so 1 1/2 times 3. That's the same as 3/2 times 3. Remember, make them improper. Make them both improper. The whole number you just throw a 1 under. And over here, to make 1 1/2 improper, you do 1 times 2 plus 1. All right. So now I'm going to have, remember to multiply, you just multiply straight across. Don't need common denominators or anything like that. So 9/2. All right, cool. And then what is that as a, oh shoot, I ran out of room. What is that as a mixed number? Because that's probably what we're gonna want. Yeah, we're gonna want a mixed number. So 9/2 is the same as 4 1/2. Because how many times does 2 go into 9? Evenly, 4 times with 1 left over, so 4 1/2. Okay, so that goes here. But really, you know what? Our final answer we're going to want is a mixed number, but since we're about to do a little bit more math with this fraction, maybe it is better to leave it improper just because we're not done with it yet. And whenever you're dealing with fractions, you always want them improper if you're going to do math with them. And we still have one more step to do here, which is namely to divide, right? So we're going to divide both sides by 2 in order to solve for x. Now over here, how do I write that? Well, I can just write divided by 2 like that. Okay, so this side, left-hand side's easy, cancels out, no problem there. What about over here? Well, I've got 9/2 divided by 2, but that's the same as 9/2 times 1/2, right? Flip the operation to multiplication, which I'm using a dot instead of x because, you know, and invert this number. 2 inverted is 1/2. All right, so long story short, we get 9/4 here. And then what does that look like as a mixed number? We've got, how many times does 4 go into 9? Twice, right? With 1 little piece left over. So 2 1/4. That is how many cups of sugar you'll need. Okay. So if you thought about this differently and you thought like, well, if I need 1 1/2 cups of sugar for 2 dozen cookies, then and I'm scaling up to 3 dozen cookies, then I'm like increasing this by like 50%, like increasing it by half, then you know you could if that makes sense to you, that's great. Like if you're thinking, okay, this is 3 halves, so half of that would be 3/4, and I'll add that on, and that'll give me this. And maybe you think that way if you do a lot of baking and have to do this kind of stuff a lot. But for the rest of us, this is the long drawn out process here. Can you use a calculator to help you here? Yeah, if you can get 1.5, right, is just 1.5 in the calculator, then multiply it by 3 and you'll get 4.5. And then when you divide that by 2, you'll get 2.25, which is the final answer. So yes, you can use a calculator, but you've got to be able to recognize your decimals as fractions and whatnot. And sometimes you'll get really nasty fractions that or nasty decimals that are hard to recognize as fractional numbers. So it's not always helpful. So back to screen sharing. I'm not going to do all of them. It just take too long. But I did the first one here. So let's see, how do you plug this answer in? We're going to go 2 and then, yep, just hit the little slash mark for fraction and then 1/4. I wonder if it'll tell me if just that one's right. It won't tell me. I have to do all of it. Yeah, let me just put something in here. This would be and six. Sorry, I'm thinking 12, 6. I'm just gonna whatever. Oh, nice. Okay. I was just guessing to try to make it go faster. Okay, so you could use the same process I used for the sugar. Excuse me, on these as well. All right. So I hope that was helpful. Won't always have time to do that. But it's nice when we can do it. Okay.
Yeah, I got a question.
Yes.
On the sugar, when you came up to $1.18 for a pound, that come up to more than $3.40.
No, it's not. Hang on, let me find where I wrote that.
I came up to 85 cents a pound, and it comes up to $3.40. Maybe I did something wrong.
Let's see. But remember, it's not measured in dollars per pound. It's pounds per dollar. Yeah.
Oh, so they wanted a whole number.
No. It's still a decimal number. Yeah, the 1.18 was right. So let me see. It was, what were it was 4 pounds. 4 pounds for 4 pounds cost $3.40, and they wanted the answer in pounds per dollars. So that just means pounds over dollars. So 4 over 3.40, and that's how we got 4 divided by 3.40 is 1.18. There we go. Oops, I should not put an S on the end. It's supposed to be just, there we go. Okay, so yeah, the point is we're not finding a unit price. We're not doing dollars per pound, because if you did dollars per pound, then it would end up being 85 cents per pound. But which is how we all talk about it. If I'm going to tell you the price of sugar, I'm going to say it's 85 cents a pound. But this particular problem, they just wanted you to write the rate upside down to how most of us would naturally talk about it. Okay, does that make sense?
I guess. Okay.
Okay, all right. So let me just say that if you did want to write it the other way around, it would be 3.40 over 4. That's dollars per pound. which would be 85 cents or $0.85 per pound. These are the same numbers, just two different ways to represent the unit rates. Okay, so let's go to 4.2 now. 4.2. We've got ratios. Okay, ratios. It's just like a rate, except the units are the same. So just real quick, a ratio is a fraction used to compare two quantities that are measured with the same unit. I want to say with the same, it's not the same, it's the same type of unit. Okay. Okay. It's just fractions again. It's just fractions with words attached to them. That's all it is, with words attached to each part of it. We can write a ratio three different ways, you'll see. So we can have three different representations. This is just simple stuff here, just talking about what a ratio is and what it looks like. So the most classic kind of ratio would just be like fractional form, because I told you it's a fraction, right? We can also write it as with a colon, 1 to 2, like that, 1 to 2. You may have seen ratios written that way before. Or you could literally just say, in words, 1 to 2. All right. Just three different ways to say the same thing. And the order does matter here, right? Like the one being on top and the two being on the bottom is the same as the one being on the left and the two being on the right, one being on the left, two being on the right. So the order does matter. Okay. So let's do an example problem practicing. We'll do a few examples, just jumping straight into practicing using ratios. All right, so on a university campus, the freshman class consists of 321 women. Oh my goodness, I can't spell today. Women and 214 men. 214 men. And I'm going to break this into parts. Write the ratio of part A, men to women. Part B, women to men. Part C, men to total. And part D, women to total. And then part E, let's say, write the ratio of, actually, we'll do part E as a separate example. Okay. All right, so this is just some practice getting used to how to write ratios. And by the way, I didn't tell you how I wanted you to write them with those, there's three different representations, right? But let's just use fraction form. we are pretty much, sorry, one second. Okay, we're pretty much always going to use fraction form. The only time it won't be written in fraction form is when when it's given to you in a problem like this. All right. Let's do part A, men to women. Only thing to make sure that we're careful of here is that we write it in the right order. We'll say 214 to 321. There it is. All right. Part B says women to men, so we'll flip it upside down. 321 over 214. So just copying down the numbers in the right order, right? In the order coming from the way it's stated over here. Now, what about part C? It says men to total. So it should be 214 on top, but what should go in the bottom? In the bottom, I should have the sum of all people at this university, well, at least in the freshman class. And if I'm to assume that there's only women and men in the freshman class, then the total would just come from adding those two numbers together, which would be 535. So that's the total. Okay, so that's 535 in the denominator there. That's men to total, and then D is women to total, so 321 over total, which I already found, which is 535. Okay, so not too crazy, right? The only thing to be careful of is to look for that distinction when you're given a total, or rather when you're asked for a total, when you're only given the two numbers that together build the total. And we'll also do a problem where you're given the total and one of the other numbers, and then you'll have to find the third number that builds the total. We'll do one of those. All right. So hopefully this all made good sense. Let me show you example 2 now, where I'm going to ask something about example 1. Write all ratios from example 1 in simplified form. Okay, so for part A, we have 214 over 321. So how can I simplify this? I'm trying to think of a number they both have in common, right? A number they both have in common so that I can simplify the fraction, essentially. So what do I do? Well, you could sit here and think about, okay, what numbers do these have in common? That might take a while. So maybe an easier thing to do is to just factor each of them off on the side using a little factor tree. So I could take 214. I definitely know a 2 goes into that. So if I divide that by 2, so 214 divided by 2, and I'm getting 107. And then that is, I believe, prime. I believe 107 is prime. So that's as far as we can go with that. You could play with 107 to see if it has another factor. Then what about 321? What number definitely goes into 321? Well, a 3 does. A 3 does by that rule for dividing by 3, right? If the sum of the digits adds to something divisible by 3, then that means the overall number is divisible by 3. It's an interesting little rule there. So when I divide it by 3, I get, nice, another 107. So that means over here, when I write this fraction with the numerator and denominator, in this factored form, I have 2 times 107 over 3 times 107, but then the times 107 over 107 is just 1, right? So it ends up being just times 1, which is meaningless. Long story short, they cancel out, right? And I'm just left with 2 over 3. 2 over 3. Okay. Part B was 321 over 214. But I don't need to go through all the trouble of factoring them again because these are the same numbers, right? These are the same numbers. And in fact, they're going to cancel. The 107 is going to cancel the same way and everything. It's just that it's flipped, right? So instead of 2 over 3, I'm going to get 3 over 2. Cool. So just this fraction upside down. All right, then part C was, where is it? 214 over 535. Okay, so part C is 214 over 535. Now, I already know that 214 can be broken into 2 times 107. 2 times 107. Maybe 535 is divisible by 107 as well. And it is. Nice. Okay, it's 5 times 107. So I just found that out by plugging into the calculator. How did I know that it should be divisible by 107? Well, just because I was like hopeful that it would be, because then this would clean up real nice. Yes, Stephen, what's your question?
Back on B, you know, it's, I don't know, Hawks is so tedious. It's, you know, you're saying simplify everything. Should you, I'll go ahead and simplify it down to 1 1/2?
Oh, no, when you're writing a ratio, when you're specifically writing it as a
Okay.
ratio, yeah, it's always number over number.
Gotcha. Okay, sorry.
There you go. That's a good question. So, yeah, like in the 4.1, when you're talking about scaling up a recipe with, you know, quantities that are given as mixed numbers, you know, something like that, when the numbers actually, when the whole number actually means something in the real world, then it's useful to write it as a mixed number. But definitely a ratio in the definition is a fraction comparing 2 quantities. So if you write it as a mixed number, now it's got 3 quantities, and then that you get like, well, and then it's not a ratio anymore. So here we have this part C trimming down to 2 over 5. And then similarly, part D, which was the ratio of women to total, which was 321 over 535. We've kind of already done the the brunt of the work to do this one as well, because we know that 321 factors into 3 times 107. We know 535 factors into 5 times 107. In other words, this fraction trims down to 3/5. Okay. Okay, cool. Okay. The book makes a good point about these numbers. Something to point out is that, for instance, this 2/3, which was men to women, does not mean that 2 out of every men from this total group, 2 out of 3 of the men are, what am I trying to say? Let me start over. 2 out of 3 of the people are men. That's not what it says, right? It says specifically that for every 2 men, there are 3 women in this freshman class, right? Now, when it's measured out of a total, 2 out of 5 here, since that denominator is a total, then an appropriate way to describe this would be, out of the total people in the freshman class, 2/5 of them are men and 3/5 of them are women. Okay, so it's just, you just got to be careful about making sure you're interpreting these things right. It's often very tempting to think about them all as being ratios out of a total, because that's probably the way you're most used to seeing ratios, is something described out of a whole, out of a total. But you know, we see 2 examples here of ratios that are not describing something out of a total. It's comparing the 2 individual quantities that make up the total, the 2 and the 3. Okay. So let's see. I'm kind of jumping around the book a little bit. Oh, before we leave, I need to give you problems to work too, for at least for a review, in addition to the Hawks assignments. All right, so another great place that ratios are useful is in reading maps and judging distance via some scale given on a map. So there's a picture here, and you know what, I'm just gonna draw it quickly. We've got some picture. And let's say some distance A, and then it and then some point B, rather some point A and some point B and some distance in between. And down here in the corner, we have a scale for our map that says 1 inch is equal to 5 miles. 1 inch is equal to 5 miles. So here's a question. If the distance on the map is, let's say, 3.5 inches, what is the actual distance between the points? So a lot of this is done for us via technology, right? Like if you want to know the distance between two places, you can literally just type that question into Google and it'll graph each of them in Google Maps and it'll calculate the distance for you via, you know, roads and stuff. But, you know, what if you're looking at a paper map for some reason and you need to know the distance between 2 points in the real world given some scale on the map? So here's what we're going to do. We're going to set up a proportion. It's like the recipe problem. Set up a proportion with our 1 inch per 5 miles. I'll abbreviate miles with MI. So 1 inch per 5 miles should be equal to the inches that I got from my distance on the map, 3.5, to some distance X measured in miles in the real world. Okay, solving this, I cross multiply right here. 1 times X, that's nice. It's just X, right? Just X. 3.5 times 5, you can punch that into the calculator to get 17.5, and that's it. Like X is already solved for, no need to divide it by anything. So all we need to say is just make sure at the end we tack on the unit of miles. 17.5 miles. Okay, cool. So that's how to use a scale on a map. Let's call this part A. Let's do a problem kind of going backwards. Let's say if you wanted to take an 11-mile walk how far would that distance be? How far on the map would that distance be on the map? Okay, so in inches, right? In inches, how far would that distance be on the map? So what do I know to be absolutely true for this setting, for this map, that 1 inch is equal to 5 miles. So I can set that up to be a reliable rate over here, or ratio. It is a ratio. Two units measuring the same type of thing. The type of thing being here is distance, right? Okay, so now I'm looking for some X number of inches for 11 miles. You notice how I'm lining them up across, right? If the unknown thing is measured in inches, it needs to be lined up in my proportion with inches. And if the known thing is miles, then that gets lined up in the bottom here. The unit should match. The unit should match. Okay, cross multiplying 1 times 11 gives me 11, and x times 5 gives me 5x. Okay, so then to finish this problem off, we do need to divide by 5 on both sides. So dividing by 5 on both sides here. Of course, the 5 cancels on the, as I've written it on the right-hand side here. I'm going to go ahead and flip it around and say x is equal to 11 over 5. Calculator, right, will tell you the answer, and you're going to get 2.2. And this is inches. We're measuring, this is a distance on the map, right? If you're going to take an 11-mile hike or walk, then on the map, that would look like 2.2 inches. Okay. Okay. Let me see what else they got here in the text. Let's spend a couple minutes looking at some Hawks problems since we have time, just a few minutes. All right, let me get logged in real fast. We'll go look at section 4.2. Student dashboard. All right. Okay, ratios, practice. Okay, says fill in the missing value in the given equivalent ratios. So they're given the ratio as in this form with colons. You could write this as 8 over 5 equals x over 20. So the point is that this is a proportional problem, like just like the map thing I just did. You set up a proportion, make sure the numbers are lined up correctly. It should be 8 over 5 equals x over 20. And then you could cross multiply and solve. Or if you like, you can say, well, look at these 5 and 20 are related. They're both in that second position, right? And 8 is related to the unknown number. But how is 5 related to 20? Well, it's been scaled up by 4, right? So that means the 8 must have been scaled up by 4 too. Now you would see that if you if that didn't make sense to you, what I just said verbally there, you would see that all come out in the wash when you do the proportion work as well. 8 over 5 equals x over 20. Okay, the ratio of 1.1 to 42 is, so I'll actually write this one down, even though it's really the same thing again. I'll write it down. So, oops. 1.1 to 42, so I'll say 1.1 over 42 is the same as the ratio, so that means equal, of 3.3 to, and then they say blank, so that's the unknown. Okay. Cross multiplying here, 1.1 times x is just 1.1x. 3.3 times 42, I'm just going to ask the calculator to do that for me, and it's giving me 138.6. Then finally, the last step is to divide both sides by 1.1. Again, I'll ask the calculator, and it's giving me 126. And again, you might say, well, yeah, because that first number is being scaled up by 3. So, right, the 1.1 to 3.3, that's being scaled up by 3. So that means the 42 must be scaled up by 3. And if you do 42 times 3, that's what you get, right? but you can always fall back on the proportion as well. Okay, go back to the screen share. Let's see what else we got. And then, oops. All right, this is straight up asking, what is the ratio here? So ratio of blue marbles to black marbles. So I see that there are 6 blue marbles. And and 3 black marbles. So it's 6-3. It says express your answer as a fraction or with a colon. So I'll use a fraction and I'll say 6-3. They didn't ask me to simplify it. If I did, obviously it'd be 2-1, right? So let's see what it does if I don't simplify it. Your answer is not in simplified form. So it's going to warn me that I should try to simplify my answer. So if I do that, what's it going to look like? It's going to be 2-1 because 6/3 simplifies to 2-1. And since they want it as a ratio, you won't just write it as a 2. You should have both numbers explicitly written. So 2/1. There we go. Okay, another marble one, another one of these. Okay. This is a good one. I know we're about to run out of time. If 84 of the 180 participants in club activities are non-residents, what is the ratio of non-residents to residents? Okay, so they want a ratio where the top should be non-residents, 84, right, to residents. But how many residents are there? I know there are 180 total people, and I know how many non-residents there are. So what I'm going to do is I'm going to subtract 180 minus 84 to find out that there are 96 people who are residents. Okay. So this is one where they give you one piece of the data and they give you the total, and then they ask you to build a ratio that involves that third piece. So you've got to use these two, the total minus this piece, to find that third piece. Okay, so this would end up being 96. And if I plug this in like this, it's going to yell at me and say, no, simplify your answer, because they say write the ratio in lowest terms. So I'd have to sit here and figure out, what goes into 84 and 96. 12, I believe, goes into both. And you would simplify it and etc. But the real point with this one is that you've got to find that 96 before you're ready to start plugging in the answer for this one. Okay, this is a good one too. I think I'll save this one for next time. I'm going to write it down. Domestic vehicles outnumber foreign vehicles by about 8-7. So 8 domestic to 7 foreign. Okay, and there are, see, now they give me a total, 5175 total. That's a total. That's the trick to this problem. How many of them are domestic? Right, so I need to, well, I don't have time to do this one, so I will write it down and we'll do it next time. Now, before y'all leave, I got some problems for you to mark for review. I'll put them in the chat, actually. If you guys need to go, you can go ahead and go, because you can only you'll see this chat even if you leave the meeting. So you guys are good to go. I'm going to go ahead and type all of them in here so you have them. A little bit more, 6.1, 17, 18. Oh. and 9.